Good morning, good afternoon, or good evening. So wherever you are. So this is Saklan Tahir. I'm Specialty Solutions Architect, focused on Microsoft platform to help our customers at AWS to migrate or modernize their Windows workloads to AWS. So today in this session, I'm going to talk about Microsoft SQL Server migration strategies. So let's start. We will talk about how to run SQL Server on AWS. Both are managed offering and running on Elastic Compute Cloud, which is called EC2, our virtual machine platform at AWS. We will cover best practices in terms of compute and storage, and we will cover the migration methods of SQL Server, both the managed migration services and leveraging native SQL technologies to migrate SQL Server workloads. And as part of the migration methods, I'm going to touch base one of the migration methods we will talk about is the database migration service. And then we will compare and contrast the various migration methods towards the end in summary. AWS has over a decade of experience helping thousands of organizations, including global enterprises in public sector like US Air Force, NASA, JPL, NIH, and of course in commercial sector. And there are a lot of customers in the health industry where we are helping their workloads to migrate to AWS cloud. So the migration and modernization of the Windows workload on AWS is a key, and we help that Microsoft workloads are running successfully on AWS platform, because AWS has translated this experience into our different migration programs, and one of the migration program called Migration Acceleration Program for Windows, which is based on our methodology of best practices and library of cases covering thousands of migration. And of course, the SQL Server is a key workload for Windows, and that will be applicable to SQL Server workload as well. We have made lots of innovation. As you can see on this screen, there's a lot of information to read, but I'm just going to highlight the SQL Server piece. So we have provided all the innovations as SQL Server grows to make sure that all the SQL Server versions and additions are capable to run on AWS. Recently, we have provided the support of SQL Server 2019 on EC2, which means that you can run your latest version of SQL on AWS as well. In parallel, we have also provided one tool called AWS Launch Wizard for SQL. And the purpose of that tool is to make sure you can easily configure your complex SQL Server environment without going under the hood. So that helps a lot of customers to set up their SQL Server golden standard, like always on, from scratch within a matter of hours. So now the question is, why SQL Server on AWS? So first of all, if you see some statistics here, public cloud market leaders dominate the Windows segment of the infrastructure as a service market. As per a third-party company called IDC, they are saying almost close to 60% of Windows workloads are running on AWS. And of course, SQL Server being a key component of Windows workload, so which means that AWS is the best place to run your SQL Server as well. Second, customers need high availability for mission-critical applications written using SQL Server. We have the best global infrastructure for running workloads that require high availability and a better infrastructure. So as part of the AWS global infrastructure, and of course, the SQL Server is part of the Windows platform. So we have spans like 77 availability zones within 24 geographic regions around the world. So these availability zones are designed for physical redundancy and provide resilience, which enables interrupted performance. And if you see this one here, so that's where we stand. Most of our customers, they feel comfortable to run their Windows workload on AWS. One of the key reasons why different organizations move to the cloud is because they need a reliable platform. Here is some statistics from Gartner, and they have provided some stats as of May 2019. So AWS was 40 times more reliable than our next competitor in the last 365 days, which means that okay, whenever customers make decision to move to the cloud, so the reliability is a key to make sure that okay, their workloads will be running in a reliable platform. The other important piece is performance and cost. DB Best, it's an enterprise database consulting company. They just wrote 2 blogs, one for Azure and one for AWS, that showed how to get the best price and performance for running SQL Server in the cloud. ZK Research, another company, they took those blogs and compared the results from DB Best to show an apples to apples comparison. And the results were very interesting. ZK Research points out that SQL Server on AWS consistently shows a 2x better price performance using industry standard Hammer DB. The first chart shows on the left side, AWS is in orange and Azure in blue. The cost of 1 billion transactions per month for this smaller is better. AWS is cheaper as compared to Azure. And then ZK Research dove into performance of SQL Server. And again, AWS in orange and Azure in blue. So SQL Server on AWS outperforms SQL Server on Azure. And it is almost close to 3 times better performance in AWS as compared to Azure. So the important thing is, while there are a lot of CIOs which we talk to different customers, they tell us that cost is not the key factor in their decision to move to the cloud. Agility, innovation are usually the center of their motivation. They are often impressed with the cost saving they see when bringing their mission critical applications like SQL Server workloads to AWS. We typically see at least 20% saving with just a lift and shift. Over the first few months, you can continue to optimize your EC2 instances for, you can optimize your instance type, you can optimize your storage, and you can get almost 10 to 20% saving when you optimize your workloads in AWS. And of course, by adopting higher level services, you can further optimize using the managed services as part of the AWS platform. And that helps a lot of customers to save almost 60% or more saving on the long run. So as many of you know, Microsoft has ended extended support for SQL Server 2008, and a lot of customers who are still running their workloads on SQL Server 2008. And for customers seeking to upgrade, we offer an automated upgrade process, which is called through AWS System Manager, you can upgrade to SQL Server 2016. So the challenge is previously upgrading to a newer version would be a time-consuming. It's a manual process requiring meticulous attention at every step, especially for SQL Server, because otherwise there can be some problem when you upgrade your application. So as part of the AWS platform, we provide SQL Server upgrade tool, which is an automated tool. You can initiate the process with one click, go have a cup of coffee while waiting, and complete the upgrade. It's pretty simple. The entire process is pre-scripted, which is a key. And also, it's a non-disruptive process with side-by-side deployments. You can validate your application without disturbing your production environment. And it is streamlined. It is super easy, like initiate your upgrade, conduct deployment, and then you are done. You can just verify your results and then get your SQL Server up and running in the latest version. So these are some key factors why customers prefer to run their SQL Server workloads on AWS. Now, for today, let's focus on our SQL Server on AWS. So I will start with some design consideration. So there are like 6 key areas to look for design when you are building a SQL Server environment, regardless if you're building in on-premises or in cloud. As you know, most of you know that SQL Server is memory-hungry technology. and it is important to have a right size of memory, processing power, and optimized storage options for SQL Server to run. AWS provides large number of options to pick like different instance type and classes, a right memory size, and of course your optimized storage I/O based on your database performance. The other important component is your network latency that play a vital role for SQL Server workloads and the actual architecture. For instance, if we set up a SQL Server always on for high availability using synchronous commit, we need to make sure that there is a single digit latency between the primary node and the secondary node. So for that, AWS provides that option, and we have, as part of our global infrastructure, we have a concept of availability zone, which means that okay, between each uh, availability zone, there is a single digit latency, which is the perfect candidate to set up the always on architecture. And there will not be any network performance issues if you follow that approach. And of course, the two components, high availability and disaster recovery, they are always the key factor for SQL Server workloads. And it depends on the service level agreements and RPO and RTO, how much data you can afford to lose, and how much time you can wait to bring your system up. So these two components are very important when you are designing any high availability or disaster recovery solution. AWS provides multi-AZ, multi-availability zone for your high availability requirement. And also we provide cross regions to set up your disaster recovery architecture as well. Okay, so now the question is, which migration strategy is right for you? We typically call out rehost, replatform, and refactor. Rehost means to run SQL Server on an AWS virtual machine or instance on Elastic Compute Cloud, in which you have full control over the environment and support of all SQL Server versions and features. A replatform means to run SQL Server on the Amazon Relational Database Service, which is a managed service by AWS that is optimized for SQL Server and automates the architecture, for example, patching, backup, high availability features that will be managed by AWS. A managed service means that we take on most of the undifferentiated heavy lifting of running SQL so that you can focus on higher level value that comes from the database. Lastly, refactor is for our customers who want to get off SQL Server and move to a cloud native database. Like AWS provides Amazon Aurora, Redshift, DynamoDB, and Neptune. And all these are purpose-built database for specific functions of different applications. And it allows you to eliminate SQL Server licensing cost, which is the biggest chunk. But today we will focus on migration methods for rehosting and replatforming SQL Server rather than refactoring. Let's talk about how many ways can you run your EC2 SQL Server in AWS environment. For customers running legacy databases on premises, provisioning, operating, if you want to scale it, and managing database is tedious, time consuming, and expensive. Customers want to spend time innovating and building new applications and not managing infrastructure. EC2 Windows is a one option, means that okay, you bring your SQL Server, you set up virtual machine, which is EC2 in AWS, and configure your SQL Server. The other option is okay, you want to leverage AWS managed service, the SQL Server relational database service called RDS. For EC2 use case, all those corporates or third-party legacy and custom applications, including any line of business applications, you can launch a database to support these apps using Amazon EC2, and underlying it's going to use the Amazon EBS volume. Corporations apps, they can, for example, if we are running MS Microsoft SharePoint, Exchange, Skype for Business, or if there's any other third-party application, so then you can set up your SQL Server using EC2. So AWS lets you run corporate applications more efficiently and flexibly while maintaining the management and control of your on-premises. So it's a most cost-effective option for hosting your line of business applications. So in this case, AWS gives you a fully managed database service if you are using RDS, which help you to build any web, any mobile, and custom business applications. For Microsoft developers, Amazon EC2 provides a flexible and agile development platform, which is kind of deeply integrated with the Visual Studio and the .NET. And also, the important thing is you have flexibility for the licensing options if you are using SQL Server on EC2. So number one, you can bring your own license, Windows and SQL Server. If you have a software assurance with Microsoft and license mobility, you can purchase EC2 Windows license included, but you can still bring your SQL Server license to AWS. And the third option is you can purchase Windows plus SQL Server from AWS, which is called license included option. So you have a number of choices on licensing your database software. You can either bring own licenses or you can purchase from AWS, as I just explained. Amazon RDS alleviates the pain of managing on-premises databases. It's built by AWS as a way to help customers reduce the complexity in supporting critical transactional applications by making it easy to set up, operate, and scale a relational database in the cloud. RDS automates time-consuming administration tasks such as hardware provisioning, database install, setup, patching, backups, any kind of automatic failover. So AWS take care of that by deploying in a multi-AZ environment, and it will do the automatic replication, recovery, and failure detection. And it gives our customers a data encryption at rest and in transit as well. It provides industry compliance and assurance programs. It frees you to focus on your application so you can give them the fast performance, high availability, security, and compatibility they need. RDS is available on several database instance types. You can optimize based on your memory. You can pick that if you have a requirement for processing. So you can pick that type of class. And also it provides you with 6 familiar database engines. So SQL Server is one of them. But if you want to use the RDS service, you can use for Amazon Aurora, MySQL, PostgreSQL, MariaDB, and Oracle as well. So as of 2019, so RDS does not support BYOL for SQL Server due to some licensing changes announced by Microsoft. And also RDS does not support Linux at this time. The important thing here is the RDS uses the same SQL Server software stack as you would deploy on EC2 yourself. We as an AWS just wrap our own management layer around it. So this service layer automates a lot of day-to-day maintenance and operations process on your behalf, and you just get a SQL endpoint that you connect to and interact with the database. We take care of all the heavy lifting for our customers. All right, so now you might wonder, what are the difference? So I'm comparing running SQL Server on Amazon RDS on the left with the running SQL Server on EC2 on the right. The AWS orange boxes indicate that Amazon provides as a managed service. In the case of RDS on the left, Amazon provides nearly all administrative functions spanning from bottom to top, as you can see, like Power, HVAC, OS, SQL install, SQL patching, backup, high availability, and automatic scaling. In the case of EC2 on the right, while Amazon provides Power, HVAC, and OS install, it is up to you as a customer to install, maintain, patch, and backup SQL Server. It is also up to you to manage high availability and scaling. Either you want to set up the SQL Server always on, or active passive cluster, or database mirroring. So that totally depends on the customer how they want to architect their SQL Server. I would recommend that you consider RDS first, so that you can focus on business value tasks rather than database tuning, schema optimization, and freeing up your DBAs to focus less on maintenance. I would recommend SQL Server on EC2 if you need full control over every aspect of SQL Server, including backups, replication, clustering, or if there is some application requirement like you want to run on SQL because of some data residency issue. As I mentioned in the previous slide, I recommend considering RDS first. So here is what RDS can do. RDS is running the same SQL Server database engine when we run it as when you run it. You would use the same management, monitoring, and automation around the database. For example, you would connect to the RDS with SQL Server Management Studio, as you typically do for your conventional SQL Server environment. And you would use SQL connection strings for your application or third-party tools to connect to RDS. RDS provides full database instance backup with point-in-time restores, and also RDS provides always-on availability group, which is the golden standard for SQL Server as an industry, and SQL Server mirroring when you select high availability for RDS. RDS also automates database provisioning, patching, monitoring, and Active Directory integration. So we have provided support for SSRS, SSAS, and SSIS packages for which is like different reporting services and analysis services. Those are available in RDS now. So it means that okay, you really have SQL Server as a fully managed service. In the last quarter, we have provided support for MS-DTC. You can also use Windows authentication in more regions for SQL Server. Now you can create in-region read replicas for your SQL Server. And the last, the Z1D instance family is supported now with the RDS, which is more, performance oriented, and then you can pick that and you can save a lot of cost as well. So when you run RDS, you get to choose the storage size and storage performance characteristics, as you can see on this slide, including a maximum volume size of 16 terabyte and maximum IOPS of 64,000. So you don't need to oversize your database. If you monitor your database, you can choose to dial up IOPS or the class of storage that you are using across two classes of, like, it can be SSD storage or general SSD storage or provisioned IOPS storage. You can also monitor your SQL Server on RDS using native monitoring tool. AWS provides CloudWatch to monitor your RDS and look at the depth of the queue of IO requests that have yet to be serviced. CloudWatch can display any or all metrics from either SQL Server or from underlying operating system, which can be Windows operating system. So we offer more on space of monitoring than just CloudWatch. It means that okay, if you are running RDS, so you will be able to monitor that with the conventional tool from AWS, which is CloudWatch. Okay, let's turn to some best practices for running SQL Server on EC2 natively. So I will start with some purpose-built compute families as part of the AWS. So when you run SQL Server or any workload on EC2, you get to choose the instance family that you would like to use. As you can see, some instance families are optimized for compute, others are for storage, still others for GPU, and some are optimized for low cost with bus-stable performance. In the case of SQL Server, I recommend running the R5 and R5D families. And the reason for that is the instance in the R5 family cost approximately 7% more than the M family, but the family for general purpose compute, but in exchange for that 7% increase, you get approximately double of the RAM. And as I said earlier, as you know, SQL Server is a memory hungry technology. If you get the better RAM, then you can definitely get the better performance. So for SQL Server, which will use as much as RAM as you allocate, the R5 and R5D families are recommended. So R5D is a variation of R5 that includes high-speed instance storage, which is local host storage, and use high-speed SSDs. Similarly, SQL Server TempDB greatly benefits from its local storage. So that's why it is important to use the R5D class. But sometimes if you are bringing your own license and you have more core CPUs, but you don't need those, so you have an option to disable those multi-threading. It means that okay, you can save money from the licensing cost perspective if you are worried about okay, we are paying per core, but you can get the better benefit of that memory and you can run your SQL Server with a better performance. So there's a link here, like different instance types. It has you can go and see that you have the ability to pick from the wide range of CPU in R5D class. It starts from the 2 virtual core CPU and it goes up to 96 virtual core CPU, and you have a wide range of RAM starting from 16 gig to 760 gig, 68 gig of RAM. And of course, the network speed is up to 25 gig GPVS as well. So it's very important to pick the right type of instance for your SQL Server, and mostly I recommend for my customers to pick R5 or R5D because they are more memory optimized, and SQL Server will run better on those instances. So the second component which is important is your storage, your volume type. So let's talk about volume types for SQL Server here. So you will usually want to use GP2, which is general purpose 2, or IO1, input output 1. These are both enterprise SSD volumes, and that's good for databases. The IO1 goes beyond GP2 because you are able to dial in a guaranteed performance in IOPS that SQL will receive 99.9% of the time. And you can select and pay for whatever minimum IOPS you need to supporting the storage latency, and lets you know that you can meet the SLAs promised to the business. Some companies will use GP2 for lower periods of demand and switch to IO1 during non-peak periods. If you have a really peak period or there's a heavy lifting workload, so IO1 is recommended. ST1, which is standard disk, are spinning magnetic disk and good for targeting backups. More on this, if you want to take the backups, you typically customers use that. And SC1 are also spinning disk that are good for low sequential throughput. So I have some customers who use target SC1 for their backups as well. So to pick the right EBS volume is also a key for your better SQL Server environment. Let's start with the migration method. So before we start the migration method, it's important to understand that, okay, first you should identify all SQL Server dependencies, not just databases and tables, but also stored procedures and platform, like always on, what you're going to use. You're going to use a mirroring, or if you need the different reporting services or analysis services. If you catalog these, you can determine quickly if you can use RDS or if there is a technical blocker. Second, you look at how applications authenticate. If they use Active Directory, you should set up AD on AWS with the AWS Directory Service. You don't want to perform authentication on premises for cloud workloads due to latency. Third, you want to look at the SQL Server versions and additions that you need. If you are using SQL Server 2008, for example, which is outside of the mainstream support, there is an analysis whether you want to continue running it in the cloud or whether you want to upgrade to later supported version. This is our recommendations, by the way, because we always recommend our customers to upgrade to the latest version. You also want to document and look at your HA and DR requirements, performance requirements, including SLAs to the business, retention policies for data, migration options, which we will cover later in the coming slides. And then this will help you to match or exceed your requirements when you move to the cloud itself. So before we start what method we should choose for the migration, we have to do assessment and planning to make sure that, okay, what workload we are moving and what is the requirement for that application to run successfully in the cloud. We are going to talk about these 5 services as a different mechanisms to support a hybrid SQL Server architecture until you have moved the whole SQL Server to the cloud. So you can remain in a permanent hybrid scenario, but we usually do not recommend this because application performance highly depends on different applications, databases, and resources in the same location. So interjecting latency from an app to the cloud to on database on premises will usually degrade performance. Hybrid configurations are sometimes used for DR, and this is an important topic in itself, though, so which is not we are covering today, but we have to make sure that, okay, if we are setting up the hybrid architecture, so how we should do that. The first way to migrate your database to AWS is to back up your SQL Server database to an Amazon S3 bucket. and then it restore your database to SQL Server in a VPC, which is like Visual Private Cloud, in a single availability zone or AZ. So backup and restore is the easiest way to move to database to AWS. Once SQL Server is on AWS, you can designate that particular server, whether in RDS or in EC2, as a primary and proceed to configure the always on or other highly available architecture that can span to multi-AZs. And you can also deploy Elastic Load Balancer in front of the server if you want to. So there is another alternative to backup and restore directly to an S3 bucket. It is storing your backups on an SMB file share on premises, as shown in the second component, AWS Storage Gateway. So that service is called AWS Storage Gateway. So that will synchronously copy your backups to an S3 bucket, from which you can restore them to a SQL Server on the cloud. AWS Storage Gateway provides a means of always providing the latest backup to the cloud until you have a cutover for that. Now, the Amazon RDS is the third thing. The step one for that is to create an identity and access management, or typically we call IAM role. So that allows RDS to read from the S3 bucket. The principle of least privilege means to give RDS no additional rights needed beyond those for its designated purpose in case of restoring the database. But the question is, what about the database if it's so large that the time to move the database across the wire to AWS is too time consuming? So say if you have a database that is 1 terabyte or bigger, in this case, you may want to use the AWS service called AWS Snowball, which supports import and export. So what we do actually, we will ship you a Snowball appliance to your data center with an 80 terabyte volume. From there, you can mount the storage on the appliance as a drive and back up your large database to a Snowball appliance. When backed up, you can shut down the Snowball appliance and the screen will fill itself with the return label and express ship the appliance to AWS, where we'll just load its backup into a bucket, which is S3 bucket that you listed upon order. So the backup restore process is the same, except that you can avoid the network time to move large backups to the cloud. And I have worked with one of my customers to move the huge database into AWS using Snowball. The last is the AWS Database Migration Service, which I'm going to touch base in more detail in coming slides, which is the AWS service to move your data from your on-premises to AWS Cloud using that service itself. Okay, so there are like some native DB migration options, so which you have already heard about that, and it might be the industry standards. One of them is using log shipping, so which is pretty old methodology, but what you do actually, you set up your on-premises server to be primary with SQL Server, standby on AWS, and configure asynchronous log shipping. On the data had to populate by standby. The standby would configure to be a primary node of SQL always on, and then the secondary node will be configured in another AZ, and then it will start replicating data to the secondary node itself. So the SQL Server would be migrated to AWS and provision high availability, but this step would work whether the database on AWS run on EC2 or RDS, it doesn't matter. So you can use for both the categories for SQL Server migration. Database migration is a newer technology than log shipping, but works just as a preceding log shipping mechanism. The principle is configured for mirroring, and the standby is provisioned on AWS, which in turn becomes node 1 for your always-on configurations. The same migration method applies to always-on availability group. In this case, there is an always-on cluster on premises, which you already have. You would configure a secondary on AWS. This server would receive all asynchronous application updates from on-premises and serve as a migration target. I recommend that you set up this secondary for asynchronous replication so that on-premises applications are not waiting for commits. And if there's any latency issues, you will not have any problem. So the Amazon Database Migration Service and Snowball, these are the two services which AWS provides. And I just briefly touched upon in the previous slide, okay, you can use Snowball if you want to move data offline. But in the next slide, I'm going to talk about the AWS service called DMS, Database Migration Service. DMS migrates your database and data warehouse securely via application. DMS includes a companion tool called Schema Conversion Tool in case if the target database is heterogeneous database. For example, if you want to migrate from SQL Server to Amazon Aurora, which uses the MySQL or Postgres engines, so of course the schema will be different. In that case, the AWS Schema Conversion Tool will be handy. But if you are moving from SQL Server on premises to SQL Server on EC2 or RDS, so the database migration service will be leveraged without using a schema conversion tool. So DMS is a real-time replication engine using change data capture. We call that a CDC technology to replicate deltas or data changes. As you can see on this slide, you have a customer data center on the left, and then you have AWS. Of course, you have a connectivity either through the VPN or direct connect. And then application users are using that application to move the data to cloud. So the first step in using DMS is to start a replication instance, as shown on the right side in yellow, like by the gears. This is an instance that will manage the application between the source and target over your VPN or direct connect, which is if you can be depending on your bandwidth and the network speed. Then you will identify the source and target database, as well as the specific tables and their underlying schemas replicate. While replication is taking place, as shown by the red arrow, your users and apps will continue to point to an on-premises databases. It means that okay, there will not be a downtime. So your apps and users are still using your database, but data is being replicated through DMS to the target database in AWS. So DMS will perform a one-time load of your data, and then it synchronizes the deltas for your on-premises databases with the AWS database. So these deltas are the CDC changes. So it means that, okay, once the bulk load has been done, you are still using your application, but using the DMS, the deltas will replicate to the AWS database. You will not lose any data, and it will be available to the cloud database in a real time. Finally, when the database on AWS is fully synced with the on-premises database, so what you have to do is you will just switch DNS to point users and applications to the new database on AWS. And DMS is generally easier to configure and use, like as compared to backup and restore, or configure a hybrid deployment using log shipping or mirroring or always on. But the DMS is very easy to set up. But the key is we have to understand the use case to see how much data we have. If it's in terabyte, then it's not the right choice. Then the Snowball we should use to do the offline. So based on the application and volume of your data, and of course your network bandwidth, but we can leverage DMS service to migrate your databases to AWS without any interruption. Okay, so this brings up to the question, okay, how to select the right migration method, and what are the pros and cons of each method? So I'm just gonna quickly highlight those here in the next slide. So this slide shows the migration methods and both what works and areas in which migration methods fall short. The first takeaway is that DMS support migrating all SQL versions, any additions, database objects, and the target can either be SQL Server on EC2 or RDS, which is the managed service from AWS. The second takeaway is to notice that backup restore also supports all versions, additions, and database objects. Next, you begin to see some limitations. For example, hybrid always-on availability groups. only replicate databases tables, but not database objects. So similarly, while RDS supports always on availability groups, it does not support a hybrid always on availability spanning on premises and then RDS managed groups. Similarly, log shipping and mirroring do not replicate database objects, nor supports RDS as a target. So you cannot use log shipping and mirroring for RDS. Transactional replication does not support SQL 2008 databases, but can be a programmatic replication option. You can use it because for other versions, yes, you can still use transactional replication. Snowball is a service from AWS. It does not keep data in sync. As I explained earlier, it's an offline device. It is sending an appliance to Amazon. However, it is good for the use case of moving large amount of data to AWS and works in a combination with DMS for the delta. So think in this way: if you have a use case where you have like more than 80 terabyte of database, you can use Snowball to send that data to have a one-time load. And after that, you can configure DMS, database migration service, to replicate all the deltas to AWS. So these are some main takeaways of the different migration methods, but each migration method has the pros and cons, but we have to pick the right migration method based on the workload, your database, your applications, and user requirement. But AWS provides all those options for our customers to migrate their SQL Server mission critical applications to AWS. And we are providing some AWS built-in services like DMS, schema conversion tool, and AWS Snowball to help and make this migration more smooth. Okay, so now I'm just gonna quickly summarize here towards the end. In this session, you have learned about how AWS supports SQL Server on both EC2 and RDS. We have talked about some best practices like picking up the right compute and storage for SQL Server. The first key area is, okay, why should we choose AWS? So because of some more experience running Windows on AWS, global infrastructure, we have a more reliable statistics, performance and cost, and of course, we provide help and tools to migrate the end of support databases as well. So the items, like for example, your benefits, of course, high availability and disaster recovery is the key for any SQL Server application, and different versions and additions inform whether you migrate like for AWS based on your requirements. Of course, there's some authentication requirements which tells us you need to stand up Active Directory in AWS. We provide Active Directory services as part of the infrastructure. You can extend your existing Active Directory to AWS, or you can set up your domain controllers in AWS, or you can use Microsoft Managed Active Directory as well if you need to configure the RDS. The amount of data being migrated is a key to whether you use a VPN, Direct Connect, or Snowball appliance. The connectivity that you have to AWS will inform you how efficient and over the wire migration would be. Because if you have a direct connect, then of course, if you have more data, you can definitely leverage DMS. But if there's an issue with the connectivity between your on-premises and AWS, then we have to be very careful which method we are picking for migration. The other key factor is the migration method also should play into your existing skills, your team knowledge and capabilities required. Identifying a new home for databases will help ensure that requirements are met for availability, performance, your management and control. From the AWS perspective, you can leverage AWS professional services. An AWS partner or an AWS solution architect can help you to decide on the right migration strategy. So you can leverage AWS and our partners because we succeeded in many migrations. The AWS well-architected framework will identify architectures that optimize your SQL workloads regarding security, availability, performance, operations, and of course, cost saving. Most customers find that migrating is the first step to the cloud, and that optimization, such as figuring out the optimal storage, compute, and networking resources, is a logical second step. So these are the high-level different strategies for your SQL Server to migrate to AWS. and I will continue to having this series. So the next step would be I will be preparing some webinar on that. Okay, how you can architect different migration methodologies and how will that work from end to end. We have added some resources towards the end. So if you want to start with the SQL Server, so to understand that, okay, how should we run on AWS and what are the key components and factors from migration standpoint. So there are some links available. So you can definitely go and start looking into that. But in meanwhile, if you have any use case or workload where you need help to migrate into AWS, so you can of course contact your existing account manager, and he or she can engage Microsoft specialty team for Windows and SQL Server migration. But if you have any question about migration methodology or moving your Windows workload to AWS, so feel free to send email to this address to get the help. So with this, so thank you so much for joining today, and hope I will see you soon. Thank you. Bye.